No, this isn't engineering hours. This is office hours. There's too many different hours. too many hours. I was messing around with the login page, and I realized that people may not understand that when you're logging in, if you hit join stage, you can participate in the event. So I'm going to make a little preamble every time that we start one of these things up and make sure that everybody's aware that they can participate in the action by joining the stage. And we'd actually prefer it because Ming knows almost everything, but not everything.
And it's good to have more people to talk to.
Yeah, that's right. We get more perspectives. Let's see. I'm going to ping the server. So one of the things we want to talk about today is toolchains. So I'm going to be going through a little bit of the background of toolchains, and then Ming and Mesh and Zach, if you guys can throw in your perspectives on how toolchains have evolved, that would be really cool, because they're not exactly like they were when we all started. Back in the day, you used to have, all of these different pieces that you would sort of assemble, and that's sort of where GNU sort of spawned out of, and you put everything together and you'd have, these different pieces that would make up what you use to develop. Now they've become more and more integrated. And of course, with that comes some good things and some bad things. And I'm sure we'll hear about everybody's perspectives on the good and the bad and the ugly throughout the course of today. So hello, everybody. If you're just joining us in the chat, like I said, we're going to be talking about toolchains today. Let's see. I got to get my screen shared. So I spend so much time making these beautiful PowerPoints for everybody. One of the things that about these PowerPoints that is a little annoying to me is that I think I shared them with one of you guys, and you have the non-Western way of dating things. So I always think that I'm in the wrong file, but here we are, October 25th, 2024. Welcome and introduction. So my name is Brandon Lewis. I'm a technology journalist. Been doing this for about 15 years, but been part of the DevHeads community for about a year. Really excited to be here. Enjoy the time I spend with all you guys. And yeah, let's get this thing started. So Umesh, you want to introduce yourself next?
Hi, everyone. I'm Umesh from Pune, India. I've been building embedded software and hardware from past 10 years for IoT solutions. Thank you.
Ming, you're up.
Hi, I'm Ming, and I write my dates in ISO 8660 format. So you always do it year, month, day, hour, minute, second, and then it just all works.
Yes. Well, I'll see if I can convert the file names to that, and we'll see how much everybody gets confused. Zach, you're up, and you're also muted.
What a way to start. Hey everyone, I'm Zach. I'm a software engineer. I've been an engineer for a bit of a decade now, and I'm really loving diving into embedded stuff. And for dating, I use the Unix timestamp. So give me the number of seconds since 1970, and I'm good at
that. Marvin, how do you count the days in time?
A timestamp guy myself. Hi, I'm Marvin, an embedded Linux developer. Yeah, great to be here.
Great, cool. And everybody in the chat, hello. If you want to, a couple of you have already said hello over there. If you want to say hello there, and if you're out there in the LinkedIn land or YouTube world, hi there as well. So today, as promised, we're going to be getting into optimum toolchains. Like one of the funny things when we started coming up with this topic was, if you zoom out, Ming said Toolchains, and then I said, what do you mean? Because you could really consider a bunch of things as part of the modern toolchain, right? Like everything all the way back from your CI and CD infrastructure all the way to operations and monitoring. If you're thinking about like an entire IoT deployment, I got a little figure diagram here to show, what a modern toolchain could look like if you were zooming out for IoT development and IoT deployment. But today we're really going to be focusing in here on this one here, the code, and then maybe a little bit of the build too. But this is where we live, this is where we're from, and we won't forget our heritage. So that being said, before we jump forward, Ming, Zach, the guys in the audience, Samesh, how much of these other areas, in plan, code, build, these other categories, do you guys interact with? How much of this is part of your day-to-day, or maybe week to week might be a little bit more appropriate. Like, do you guys use planning tools? Do you guys have a continuous CI/CD infrastructure that you leverage?
Mm-hmm.
Planning, I know that concept. I thought we just sat down and wrote code.
Yes, right. Yep. No. So but actually, seriously, in terms of your build environment and your development environment, that's what you're looking at every day. But are you guys plugging into other infrastructure? And if so, what are those things that you find yourselves plugging into? I mean, I know for you, Ming, you're doing a lot of consulting work. Are you forced to come in and do, fit into whatever systems and processes the client?
Yeah, you always have to fit into what the customer is already using. It's very rare that you can actually convince them that there are better ways of doing it. And just do it this way, please. No, we've been doing it this way for decades.
Yep. How about you, Zach? Any of this stuff in particular?
Okay. I think if you're a developer with, as most people are, with something that is in production, you're probably using almost everything here almost every day. There might be like days where you, like when I'm in the columns, you're using something, you're making tickets, so you're planning, although sometimes developers plan on GitHub, and then you're using your IDE to write code, and you're using things like GitHub to collaborate, or Bitbucket or GitLab, and then you'll use Circle CI to push to the cloud when your current update is ready, and then you'll use something like Prometheus or Docker or something to deploy. And then you have Prometheus at the end to look at what is that. So you're using this stuff, or someone in your team is using this stuff every day, I would say. So all tools are very relevant here. It's stuff you want to be comfortable with. Yeah.
I do want to come back around specifically to release and deploy. We've talked about that, Docker, Kubernetes, et cetera, a couple of times recently. And, also the ways that not only you can use them to deploy things, but you can use them in development. So that'd be an interesting thing to touch on towards the end. But as I said, we're all really from this place. So, you've got your compiler, your assembler, your linker, your loader. And actually, it's funny these days, so much of this stuff has been abstracted in certain cases that a lot of people don't even understand that these are all various components that are allowing them to do their build. I want to start with you, Ming. When you were first getting into CS and computer engineering, what were the different components that you had at your disposal, and then how did you work with or put them together, stitch them together? Well,
I'm going to say, when I started, everything was hand rolled. So the first thing that you would have to do is compile your compiler, so that you could actually then start creating the rest of the other code. There wasn't really that much done for you. Everything was just hand built.
And then as things move forward, were there discrete like assemblers, or were you still building the assembler, I'd assume?
By the time I got into it, there were discrete assemblers, discrete linkers, discrete compilers. So all of the tools were individual, but they just weren't pre-built.
Okay. And then what was the process of integration then? I mean, this was not right now. We're talking about when development was seriously phased out, right? I mean, there was a very like clear lines between, one part and the other, like when you went to compilation. But if you had these discrete elements, like how were they packaged up to you as a developer, or did you have to go and stitch them all together?
You had to go and package them all yourself. So you build all your separate components, then put them into user local bin, and pull everything together.
That sounds like a pain. Well, we've sort of moved on since then. We've advanced, and again, this is one of those places where it may be for the better, it may be for the worse. I think there was a point at which, Zach, you were talking to somebody in the server about linking and linker files and linker scripts. And that's something that we brought up a couple of times, that a lot of developers probably don't even, why would you ever even do that? Well, back in the day when what we were just talking about with Ming, it's like, well, I mean, at this point, you would have had to have been very familiar with some of those things. Today, this is really what I think most of us are accustomed to. So, you've got your nice little package of VS Code or Embedded Studio, and, it's already got your compiler, your linker, your debugger, everything is already integrated there. You can swap some things out if you need to, but pretty much, your entire development environment is set up there for you. So what are you guys using? I mean, I think we've all discussed that as a daily driver. VS Code, I know, Ming, is something that you guys use. I think, Zach, you use that too. What does your tool chain consist of today? What are the key elements of it? How about you, Mesh? We'll start with you.
Okay, so like Ming says, Ming started with where you have to compile everything. I mean, you have to build your tools and then you can use the tool. I enter into embedded when the tools were there. There were too many tools, and then you have to test every one of them, and most of them will discourage you because the setting of the tools in IDE was very complex. So I have been used quite a few tools in past couple of years, like Yagato, Code and other. And right now I'm just settled down with keeping things very simple. So most of GCC, ARM toolchain, and also like AVR GCC is good enough for me because I work with two portfolios, 8-bit and 32-bit. For 8-bit, I use Microchip Studio, and I want to move to MPLAB, but I'm still resisting it because I don't want to waste too much of time, because people usually don't talk that migration cost you time, and I'm not really ready because people probably know already there were so many version has changed in the past year. It started with I think AVR Studio, then there is a Atmel Studio version, and then so many things. And for 32-bit, I use Cube IDE, and I personally prefer to have everything into single package. So the reason, because probably I worked a lot with cross-functional roles right now, I don't have that mental bandwidth to configure that tools and then go back and look for references. And I mean, they might be very good, but I prefer maybe a very specific proprietary IDE is fine for me from the vendor supported. Yeah.
Does it break up? Are they here?
Sorry, I was editing I was creating a poll, and it wouldn't allow me to leave the poll. So I think that brings up an interesting point. Amesh, when you go into a vendor specific tool, usually you're doing it, they're providing a lot of extras on top of it that they perceive can help you accelerate your development. Now, this is a big problem when you're in a creative pursuit. Frankly, coding and building things is creative in a lot of ways. And once you get to a point where somebody has provided you every single thing that you need, you lose a lot of the flexibility that you would otherwise have. I'm interested to hear, Marvin, what's your development stack look like these days?
I try to stay away from IDEs unless I'm forced in a situation where I need one. So I tend to use CMake or Make when I have to. And basically for a code editor, I primarily stay within Visual Studio or Emacs. Yeah, but basically stay in the terminal for all my building purposes.
But Emacs is a complete IDE.
Yeah, why using Emacs?
I don't use it. I don't use the full feature set. I just use it as a nice editor. I think I really like the customizability, and I was more pushed to it because of this. Yeah.
You, Zach, you're up.
Oh, I'm up. So what do I use? There's two modes. If I need to ship something quickly, very cheaply, I'll go with the meshes way. I will use the proprietary build tool that comes with whatever thing I'm building on at that point. I'll try not to use Arduino, but if I have to, I will. However, my preferred way, and over a longer term, you'll find me brewing something at home. So I'll pick a compiler, I'll pick a debugger, and it's kind of this thing where if I spend a year using it, the next year it can be my go-to. So you have something to hold. And as I've done this over a while, I've come up with like a little setup. And I'm sure everyone here has a little setup of things they can just quickly pull up and use really quickly. For me, it's like all of Linux.
Yeah, I just pushed a poll out, which was, what's your preferred tool chain? Is it vendor provided? Is it all open source? You just use, everything that's in the GNU basically, or do you stitch together different pieces of, from what you prefer to use? So throw a vote on that when you guys get a chance. I want to hear, Ming, what your different. I'm assuming that, as a consultant, things probably have to change potentially based on what the project is, and who you're working for and working with and working on. What's your preferred one, and what do you have to do?
It doesn't actually, for the tool chain itself these days doesn't change that much, because Linux is a lot more standardized. Even though we've got, it's Linux, we've got choices. There are choices on every aspect of things, but it will always be some kind of variation of GCC, GDB, etc. But given that most of my work is based around Yocto, and Yocto actually, as part of when you create your Yocto project, you have an option of creating a complete, it's not only the toolchain, it's a complete software development kit that contains a toolchain. And it's just, when you build your image, you just go for the option of give me the complete SDK, so I get a full toolchain from my build. So because I stick in Yocto,
yeah, yep,
I've got it.
That's actually a really good point of distinction. What is the difference between an SDK and a tool chain, right? Like, sometimes those become kind of synonymous. So could you break that down?
Your tool chain, or to me, the tool chain is your basic compiler, linker, assembler, debugger, all the things that you would need to actually create binaries. Whereas when you're getting into a complete SDK, you've now got all of your libraries, the utilities, the kitchen sink, the whole lot is provided for you. And that's much more what you get out of a Yocto project build.
Yep, and I just added. I had this little animation there. It's like, okay, then the next thing you add on is really you're starting to get into libraries, right? So after you get through a lot of this stuff, here's you got your VS Code base setup, and then you start getting into libraries, which a couple of people have already pointed out. After that, then you get into vendor toolchains, and this is why we were talking about people trying to help and maybe making design a little bit too rigid sometimes, because here once you've got your base set, like you're talking about your assembler, your linker, your compiler, all of that stuff, and you start adding libraries on, a lot of semiconductor and silicon vendors said, hey, well, why don't we just start adding in all of the things that would help somebody get towards a specific end application, right? So you can see inside of a lot of the vendor offerings, and Umesh was talking about not wanting to get too far into some of them. They give you a suite. How does that work out for you guys when you start going into architecture-specific tool chains with the vendor-supplied set of libraries, a lot of which are probably open source, and they found out of some community. What's your experience like? Umesh, I'll start with you since you brought it up. Do you prefer it? Is it case by case?
No, as I said, I I prefer to go with vendor provided, and I have seen a lot of instances, lot of my projects. One of the case where I was using CC, I forgot the number actually, it's from the TI chip, and I tried to implement the Zigbee stack on that. Now, the example code and everything is provided, which can be easily portable with the IDE. It makes it very easy than spending time and figuring out how can I port this to other tools, and then even everything is built in, from the SDKs to example code to the debugger compatibility and everything. So I think, and once I was working on building a beacon based tracking device for IoT, and then I experienced the same thing with the Nordic SDK. So I think it makes a sense sometimes to not to move. So I'm right now in a position where I stick with, as I said, vendor provided. But if somebody have a time, somebody is really skilled in a way that they could quickly make that, because I'm not a person who enjoys so much time spending configuring. uh, just try to build, make it work, and that's it's finished there.
So one question I have for all of you guys is, when you start going into a vendor specific tool chain, like I've done it, you guys have all done it. One potential fear here is that if there's so much already provided, like you talked about with the example code, like a lot of these chip companies are becoming product companies, right? Because they are putting so much stuff in that they want to enable, their customers, that they're moving further and further and further towards the end application and really doing a lot of the work. Are you concerned, of the fact that if you're building a Bluetooth-based device that 99% of the differentiation has already been addressed by somebody else or something that was in the tool chain, and your competitors are probably using, almost exactly the same thing as you? And if that's the case, especially for you, Mesh, because you develop products, how do you differentiate?
I think people very loosely say, okay, if you have a certain stack or certain chip and certain software ready-made, but I think I have seen for every tool and every technology that you work with have its own learning curve of somewhere 1 year to 2 years to really get the outcome from the hardware that you're building. It's not very easy to do it. And another aspect is, because when you're building a product, or maybe some sort of Zigbee solution or something like Bluetooth, whatever, I think if somebody could make it, that doesn't mean that they would compete directly with you, because there's a whole lot of thing, how stable it is, what the volume it is, and where they are in the process. So I don't really care that much. But I have seen many people, including me, spend a lot of my time doing in a wrong way of development, where I'm doing a lot of configuration and thinking that I'm doing development. So
Yes,
so
that's very.
then I realized that, okay, I'm doing all these things to and just assuming it as a development wherein I don't have any substantial product. So I don't care that as as much as you go deep into particular technology, whatever it is, whether it's a Zigbee or Bluetooth or something, I feel even 4 year, 5 year or something, you always feel like you don't know nothing about it yet. So the more your trust is, no matter, even if it's a competitor, even if he has what you have, because you also started the same place, I don't think it's easy to compete. So I don't care that much.
What do you think about that, Ming? You know, about the homogeneity of solutions, especially if a vendor is pushing you in a direction, right?
Well, I mean, there's I think there are, yeah, okay, so everyone's going to be, I mean, having actually done some Bluetooth stack work myself, where, yes, I took the Cypress or the Infineon as they are now, their Bluetooth chip, took their example code, and then built on it. But it's not the Bluetooth that provides the value, it's all of the applications around it. So I don't care if anybody else is using the same stack with the same example code, because they've not got my product.
Yep. Which is also why I think I've talked about this before. We've discussed the end of embedded, right? Because really what this does, what this vendor specific, these vendor tools do, these vendor tool chains do, is what Ming just said, is they essentially say, we're going to take care of every single thing except the application, right? You focus on the application and we'll do everything else. There's not a ton of innovation that you're going to find, especially as a small to medium-sized enterprise. I mean, you're not going to be able to build Bluetooth, right? Like that's not going to happen. And if you have an aspiration to go do that, it's you should come talk to me or come talk to somebody, because the road is long and hard. I remember I was at a convention 5-6 years ago, and there was a gentleman who had talked about how he was developing a mesh networking, a short range, low power mesh networking technology for consumer devices. And I was like, have you heard of Bluetooth mesh? Have you heard of Zigbee? You know, like the market's already the market's already saturated. You know, you kind of don't have a chance. So if you're focusing on the application layer, how much of embedded development are you doing anymore? I think that's up for debate. I know that Ming loves them some vendor tool chains, don't you?
What gets me, I think, is actually, we touched on this when we were talking about IDEs, of when everything is so integrated. So for the Cypress, the Infineon Bluetooth stuff, I used the PSOC programmer because that is what is provided. I personally struggle because it only runs on Windows. So that has immediately put my back up because I can't sit there on Linux. And everything's hidden. I don't actually know where the compiler is. It's all there, magic. And personally, I don't like that. I like to know what's going on.
Yes, but you may be in the minority. You know, as one thing that's interesting, especially as we get more, as so much of the industry, especially in the microcontroller realm and even in the microprocessor realm, is based on ARM, right? It's like, what is really the difference or the value, right, of having a certain vendor specific one? Now you brought up PSOC and, you know, Infineon, and that's a whole different ball of wax, right? But in the ARM world, I mean, you know, Jamesh, you use Cube IDE. What's the difference between Cube IDE and essentially pick any other one, right, that supports ARM? I mean, I guess they may have a couple of different libraries, and you know, they may have some specific tools, but is there much of a difference in your experience?
I think it's just the choice that how people goes about, how people choose it with their preferences. But I agree that when you use an IDE, which are open source and popular one, like let's say Visual Studio or Platform IO or such kind of IDEs, they are very flexible because you can install lot many plugins and libraries externally, which you probably, and you can move from one controller to other controller. So you have that freedom there. So I understand that, but I think the major difference is like how efficient you are and how you enjoy the process of porting, configuring, document it, keeping it in a backup for every project that you go back and forth because you keep changing things. So I think that is the difference I see across. That's why, uh, ever since we talked about controller, I don't change too much controller for a development process in the companies. There are people who keep experimenting, changing, uh, unless it's very big, substantial difference, something very unique. We don't change much because we have a stack ready, and so yeah, that's how I see things.
Serial wire viewer, some of the very specific, functions and features that you use in Cube IDE. How would you go about doing something similar in other IDEs, or is the Cube IDE just more intuitive, or or are you just more familiar with it ultimately?
Actually, when we develop a solution, you probably just use a Sega's tools, right? Debugger Professional. And then you have a Sega's special utility application which takes care of that part. So you are basically out of the IDE. Now, the IDE is not at all in the picture. So even if you use Visual Studio Code or something, that's okay, because in the end you just create those files and then load it into those applications to analyze the debug traces and other things. For me, I use it because to keep things simple, if I'm presenting something, because I started with CubeID, so probably I'm comfortable with those features, so I quickly use it. So that's, but if the serial wire viewer is the feature of the Cortex M, that's from the ARM, so it doesn't have anything to do with the tools. So tool is very much of a personal preference, how comfortable somebody is, whether the goal and objective is to build the application and enjoy the configuration part. The one reason I scared sometimes to use some open source or free tool, because in the past 10 years I have seen a lot of IDE came and then wipe out from the market. So like you may remember there were an IDE called KuCox, Co IDE for ARM. They were also using GCC. It was very big project, by the way, open source ARM debugger as well. And then there were a lot of tools I can talk, and the things goes on and on. So I'm a little bit scared, and now I just want to play safe.
Yeah, there have been a ton of IDEs that, and we even had a one of these sessions on IDEs a while ago. And ultimately, I don't think. By the way, I don't think VS Code is completely open source. I'm just going to make a little caveat there. But yeah, I'm not really sure that it makes that much of a difference. Do you, Ming? Do you think it makes a difference? Do you think that I mean, is there something in, for example, in the PSOC, in the PSOC development environment that you can't access by any other means? Are you forced to use it?
To be honest, I don't know, because I only go and touch the PSOC programmer when I have to.
Yeah.
So I don't know the tool that well.
Mm-hmm.
There may be ways of hooking into other bits of it, but it's a case of I go and do what I need to do and then run away and go and find and lie down in a dark room for a couple of hours.
Yeah. And play with the toys that you want to play with.
Yeah, get back to Linux where I can get my hands dirty again.
For sure. Yeah. How about you, Zach? I mean, vendor-specific tools. When do you have to use them? What do you like about them? What do you not like about them?
I try not to have to use them. Am I muted? No, I'm not muted. So I try not to have to use them. That's generally my. So I have a couple of years ago, maybe 4 years ago, I was getting into embedded, and the way I got into embedded was being a web developer that started writing code for microcontrollers in Rust. And the way I got into writing code for microcontrollers in Rust, I used the Rust's embedded hull. And at some point, I was really struggling for that. And then the more I spoke to people, it turned out we could, even when I was speaking to someone who was quite knowledgeable in the hull, at the time it was quite new, it was 0.1 or something. We ran into a problem where I didn't know whether I was fixing the hull or I was fixing my application. And this happens over and over. Like ST gives you UART drivers, and then you're stuck for 2 weeks with a UART problem, and then it's ST's code, and then you could have bit banged 2 things and it would have fixed it. And this thing keeps happening over and over again, leading me into this path. And I suspect Marvin is the same because he builds compilers for fun. I don't know why. You want to know the thing for yourself so you can use it when you want, as you want. And then in the beginning it won't be as fast, but at some point the gains will just start being so big that you're moving faster than others, even though it looks like you're doing it the hard way. But it's just because your driver could be 500 lines or it could be 10 lines, both ways.
Marvin, do you have anything you want to add to that?
I'm really torn about this because currently we're having a problem we're facing at work where when we started a project, we tied ourselves to the vendor toolchain that for the terminal, the payment terminal that we got from that specific vendor. But now we're no longer getting terminals from that vendor. We're getting from a new vendor. But the problem is we want the application to do exactly the same thing. And in retrospect, if we did most of the things that most of the lineup stuff around open source software, would have been able to easily port these terminals code into these other ones. But right now, we have to start from scratch to pay for these other ones because refactoring it is a nightmare. So I think in picking vendor toolchains or open source, it's something that I'm not leaning towards either, but it's something that I'd have to think of a lot basing off the trajectory of the project to take in the future.
Right now, there's a sales guy somewhere saying, "Got him." I think that's one of the most important things here. I think to note is that the silicon vendors understand a couple of things. They understand, especially as we move into more and more ARM-based stuff, they understand the power of software and the power of the tool chain, right? And Marvin just explained why. There's 2 parts of this. One is if you want to move, it's going to be much more difficult. But the other side of that too, the more friendly side, is if developers get used to developing with a certain group of tools in a certain way, like Ming was just talking about, I don't go into the VSOC realm unless I have to. And Amesh really he prefers the Cube IDE and necessarily, right? That's probably going to default a lot of decisions that you might make if you're starting from scratch, right? And a lot of this has to do with the development. I mean, STM32s are not wildly different from a lot of other offerings on the market. I mean, there are a lot of different SKUs, right? There's a whole lot of different options, but there are other, comparable micros from other semiconductor vendors. But if you are totally invested in the Cube IDE at this point, and the tool chain and everything that has to do with it, you'll probably go with what you know. Yeah, go ahead.
I want to add, like, once I was working with one of the TI's chip, Texas Instruments, and it was very specific chip for specific applications. I couldn't name that application, but it was very specific chip for specific application. And you get, if you stay with the vendor and if you have a good volume right? You get a lot of help from the companies, which really speed up your time to market. Okay, so you're backed by a volume, you promise, and now you have speed up everything because ecosystem is ready, tools are ready. So I think that also become very important. Then you're going into the open source world, and then diving into finding chip, then tools and stuff. So I think that's also important to approach the solutions in IoT.
Oh, I forgot to bring up there was a comment somebody talked about I think hardware debuggers at some point. Somebody brought up. Anyway, I was just wondering, it's like, does anybody not use Seger? I mean, in the debug realm, I mean, is Seger JTAG basically like it? Is it the end all be all? How about you guys?
Depends what level you're going to. Most of the time, I'd say I don't bother, but then I'm not looking at hardware.
Yeah.
So I'd be
yeah,
looking at, for me, GDB does 99% of what I need to do.
Yeah. How about you, Amesh?
The interesting part is that many of the early development, I didn't even use debugger. Like first few couple of years, I managed to build solutions. I mean, it's quite funny, but UART really does many things. I mean, if you use skillfully UART for debugging, that also does the job. So it doesn't mean like Sega's tools are just, I think it's the entry point of serious debugging, I would say. And
Okay.
there may be some very advanced tool which probably solves much bigger problem. I don't know. As much as I know, uh, in IoT, this the hardwares are not very super expensive, right? Their volume, and then they are like a Bluetooth and all wireless connectivity. So, and that's why many people say like in IoT, hardware doesn't bring you money. If you want to make money, you have to make it through the software. So, but I would say if you want to position the Sega's tool, they are very good at serious entry level tool when you enter into the debugging room.
So I actually brought this for Ming. I threw this up here. The stop including me gif on the vendor toolchain diagram, which was if you put too much stuff in here, it ends up eliminating a lot of the flexibility that you may want. And so Ming, I think I'd like to transition out of this topic with a question for you. Is you were talking about not being able to know what's going on in the PSOC realm, under the hood, and that making you uncomfortable. What would it enable you to do, perhaps, right? If you could see further down into what was happening inside of the system, why does it matter?
It matters to me because of the way I think of, I want to be able to take some code and run a compiler on it. I don't want to have to go through an IDE. So when I'm being forced into the IDE and forced into the IDE's workflow, it takes choice away from me. Several times I've just been, I just want to change a couple of lines, compile it up, test it real quick, which I would normally do if I'm on a Linux system. I'll just do it on the command line and say, oh, right, here we go. Yeah, oh no, that doesn't work. Try again. So I can get a rapid cycle. Whereas if I'm being forced because I don't know where things are, I've got to go their workflow, it slows me down and it jars my way of thinking.
After that, and after the comments from Zach and Amesh, I wonder, it's like, why don't we just do every single thing on top of development kits and just not even worry about any of this? Because I mean, that's really what it seems like is they're trying to happen, right? They're trying to push us to, right? Buy this reference design and buy this development kit, and then we're going to provide an abstraction layer, and you just write. You don't even need to worry about hardly any of these things anymore, right? You're just going to write an application on top of it and write us a check, right? I mean, that's why there's so much support there for you, Mesh, right? They're pushing you in that direction anyway.
Yes.
You agree?
Yes, and time to market is also very important. Someday this tool would go online, so they will be live web based. Now there would be a lot of OS agnostic behavior, like you have the operating, because early on, if you go 10 years back, it was a big debate, like some tool is available for Windows but not for Linux, and if it's for Linux it's not for Windows. Right now that question is gone out of a window. So very few tools have this limitations. So maybe next 5 to 10 years down the line, where you are saying everything will happen over just a layer, maybe it could be a Windows application or it could be web application, it doesn't matter how the world unfold in AI, we'll see. But surely we are going there.
What were you gonna say, Zach?
The feedback cycle that Ming brought up, that feedback. Oh, okay. So let's go back to like a really first principle of this stuff. Developers are humans, number one. So that feedback cycle that Ming is mentioning, it sounds like a small thing that Ming wants to get feedback quickly, but that's the difference between you sending a developer off to debug something and it taking an hour versus a week. It could be the same thing. Like if I just don't want to use MPLab and you're making me use MPLab, the task is getting done on Thursday, not on Monday morning, just because of that. So there's things of the sort that we need to account for that we can make all the same choices. We can choose the best tool for the developer. You can take the cow to the water, but if the cow doesn't want to drink, you know, so you have to consider things like that.
Yeah, no, agreed. All right, gents. Anybody in the community have any questions or anything they want to add? I mean, Drew has been going off here, telling us about what his tool chains are and things that he's used. Let's see. He's brought up Lauterbach. Yep. Okay.
Yeah.
I
I definitely agree with Drew's comments on the PSOC.
What is he saying here?
Saying that there's the lack of documentation, it's a very point and clicky, and it's just not very intuitive.
Actually,
it keeps on throwing stuff in that you're not sure. Where did that come from?
Yeah, this is before we move on. Actually, I think this is a really important point. So, in my experience, when I've looked around vendor provided development environments and tool chains, a lot of them they're sort of what you were talking about at the beginning, Ming, where they're like you talked about, like piecing together a compiler, assembler, a linker, right? They have similarly gone and pieced together a lot of pieces from out in the wild, and that leads to part of this problem, right, that Drew was mentioning, which is let's go pull a little of something that's already done over here, a little something that's already done over there, put our little magic box stuff in on top of our hardware, of our architecture. But that means that they don't necessarily, in a lot of cases, actually know where the source is of all of these different things. And this can present a lot of problems. I mean, you're going into this development environment expecting that the people who made it, or at the minimum have some very good knowledge and documentation around what's going on there, and that may not always be the case, which can certainly be frustrating, as Drew was pointing out. Anything to add there? Any horror stories besides PSOC?
Well, I'd say instead of the horror story, you can say this is why I love the Yocto toolchain. Yeah. Because I know that if I'm using a toolchain built by my Yocto project, for starters, if I'm compiling something and I've compiled it against that development kit, it's going to run on my board. And then the other thing is, because I kind of built it myself, I know what went into it because I put it there.
Yeah. Sometimes when we have these conversations, I get sad because I think about like, the abstraction, like the continued layers of abstraction to the point where you just don't know what's happening, right? And what do you call them, Zach? Script kiddies? It's enabling what Zach calls script kiddies.
Yeah, I mean, everyone starts as a script kid. No one starts. You always start by copying Hello World and seeing if it's going to run. So we all start as script kiddies. We just have to go past that.
Yeah. All right. Very good. Well, we've had Jason Schwartzman up on the slide long enough. we don't smoke. It's bad for you. And we did that. So I would like to ask everybody here, and I'm going to throw a poll up really quickly. In terms of release and deploy and then development, how many of you guys are using Docker, Kubernetes, or similar? And if you weren't around a couple of weeks ago, we talked about this. And
I use Docker as part of my CI, but not actually within my deploy. So when I've got a CI system set up so that when I commit to my GitHub, there is an automatic action that will fire up a Docker container, build my system, and then get it ready to deploy. But then I will deploy it through Mender, which is the system that I'm currently using. And that will then send my image across to my remote device.
Do you consider that some of these tools are now part of your tool chain? I mean, like at a broader context, like zooming out, because the way that you use it, Ming, I mean, it really is, I mean, even through Mender, right? Because I mean, if you're using Docker back in your integration and then you're using Mender, right? I mean, you're really starting to create something that is going all the way from your code to even deployed devices, right? And if you're in CI/CD context, right, where you've got over-the-air updates and you need to make an update, I mean, it kind of is, isn't it?
Technically, I'd be calling it my workflow rather than my tool chain. But that's semantics.
Yeah, I know. Yeah, it is. But I think it's important from the context of, if you think about a target that would be sitting on your desk, right? I mean, kind of what the whole point of IoT is, making that in the wild, right? So necessarily everything that would connect you back would be part of your tool chain at that point, right?
Yeah, there is an argument for that because everything has become so integrated, it's more difficult to separate it out.
Right, to blur the lines. Have you why did you select Mender? And have you used any Mender alternatives?
I've looked at various others. I mean, just looking at how much time we've got of the journey I took to using Mender, but it has just been simple integration because I can build it into a Yocto project because there are pre-built layers and I just go, there we go. Mm-hmm. As well as it had great support for what I was trying to do. So Mender as an IoT over-the-air update system just ticked all the boxes that I needed at the time very nicely. That's the very short version of it. We could do an entire office hours on OTA.
Is Mender free? Are there paid versions of Mender? I think they're paid versions.
Premium. You can get the basic version, which is completely open source. But if you want things like the Delta update, so you're only having to update the changes to the image. If you're wanting the remote access, so I can actually get an interactive shell on my remote systems, you pay for that.
Okay. And that's not part of your tool chain, your interactive shell on your remote systems?
Depends on how remote they are, because the one that sits on my desk, no. Mm-hmm. But the ones that the other side of the world, yes. Yeah.
Okay, very cool. It's interesting. It's interesting to me, obviously, because I put the slide in here twice. When you zoom out and you start looking at, wow, what started out, over here, right? I mean, this was really the universe before, right? This was everything, and it wasn't even all of this, right? There weren't integrated development environments or anything like that. But now. Right. No. But now you take a look and you're like, wow, look at all of the different phases in this, and you don't necessarily have to use all of them, right? It's not all are required, but it is interesting to look at how this has evolved and all of the things that are at our disposal today. Hey, Drew, I'd love for you next week to come and sit up here with us because you always have a lot of good stuff to add. I thought about inviting you onto the stage right now, but I don't know if you're like in your underwear or anything. So it'd be great to talk to you next week. All right. Well, that sort of takes us through the presentation today and the discussion. And actually, speaking of Drew, he put down, is anybody familiar with Bluetooth hands-free profile development? I'll ask any of the people who are in the audience or who are up on stage. Have any of you guys worked with Bluetooth hands-free? Because Drew had a question about that. It's in the server there. But if you are, check that out because I think he needs a little bit of insight or guidance. So, yep. All righty. Got a couple more questions here that are going to be in the PowerPoint. Noor, actually, the community manager, is building out a place to put all of these. Right now, I know I said we'd do that last week, but we'll get them up before the end of the weekend for sure. So you'll be able to download all the office hours notes and, hopefully, if you're feeling altruistic, help out your fellow devs. Coming up are some engineering hour sessions. Umesh, do you want to talk about what we're going to be doing on Sunday? And then Zach, if you want to talk about the next couple after that, that'd be great. Umesh, you first.
Yeah, so as we are exploring FreeRTOS in this engineering hour, so anybody who is working or exploring FreeRTOS these days could consider joining us into engineering hour this weekend on Sunday. We will be exploring task utilities, some key task utilities, which is good to know if you ever worked with a project uses FreeRTOS. And also we will be diving a little bit how to handle interrupts into the FreeRTOS framework. So many times we see this situation where the task starvation that we all faces at very elementary level, but I think it would be amazing to see how the interrupt will be handled between the task. So if anybody is interested, I'm looking forward to see you this Sunday.
Zach, what is control and what is FreeRTOS?
Control is running on a treadmill. So you run on a treadmill and you go forward, but you don't go forward, and the treadmill goes backward, but you don't go backward, and you stay in the same spot. That's control. And FreeRTOS is a tool we can use to give you control. So if you come to that, we can talk about that and how you can use it in embedded systems.
Yeah, that's great. And I think it's also interesting that the topic that you had sort of put AI as sort of, at first we did DSP, then control, then AI. What do you plan on for that session?
For the control session?
No, the AI one.
We're basically going to combine. It's the way that series is designed is so that we're building up from DSP into control into AI, because that is generally the thing. I know we talk about protocols and architectures and all of this stuff, but these are all just tools for data. Taps for data. Once you use UART to get data into your application, now you have to do something with it. And usually that, if you're dealing with hardware, you're going to do either some DSP, which is cleaning up your data, control, which is using the data correctly so that your car doesn't accelerate when it shouldn't. And then things like AI is like, you now want to detect things and tell the accelerator what to do based on the things that you're detecting. So we're just combining things and building up slowly into the thing. Yeah.
I have a quick question because I know we're almost out of time, but it's for Ming. Have you ever used AI in a control system as an input to a control system, or is just maybe just an additional data point?
Yeah, to me, it's just an additional point. And AI, I've only used it as an output.
Got it. Okay. All right. It's always interesting to me when you think about everybody talking about machine learning and stuff in like a factory context. It's like, okay, I could see the application of it in a situation where you're doing computer vision for something on like control or like quality monitoring or whatever. But like beyond that application of it, if you are using it to do like real-time control, I don't think that the version of AI we're talking about could be much more than just an additional input if you're going to use it in that context. So anyway, thanks everybody. I really appreciate it. Drew's got a he's typing something from his chair in his underwear. No, but anyway, no, he says nothing. Okay. All right. Well, if you have anything that you need from the community, please drop it in the Discord chat. You can go to discord.gg/devheads and you can find all of the good conversations we have going on there. And we'd be happy to help you out if you have any technical questions. Again, if you are familiar with Bluetooth hands-free, please jump in there and find Melta 101 and give him an assist. Other than that, we've got a bunch of resources here. Like I said, we'll get these up into a place where you can pull them down and have a great weekend. For everybody who's going to engineering hour, we'll see you on Sunday. Thanks, guys.
Thanks.
Bye.
Happy weekend. Bye-bye.
Bye.